All right, so we're going to talk today 4.1 scatterplots. Oh, we might actually get time to watch our video today. Scatterplots and correlation. Correlation. Okay. So a scatterplot is a graph that shows the relationship between two variables. Okay? And we try to put the explanatory variable on the x-axis. Okay? Now, this is kind of a first step of analysis. But you should do more sophisticated analysis, such as regression, which we're going to learn about tomorrow. Okay? So, things that we're looking for. Number one, things to look for. Number one, you want to look for striking deviations from the pattern, such as outliers. Number two, is it a strong relationship? And three, is it a straight line? We hope that the answer to that is yes, because if it's not a straight line, we're not going to teach you that in here. We're just going to say, yeah, it's more complicated. And four, or maybe I should say 3A. Here, I'll do it this way. 3A. Is it positive or negative? Okay. Now, let's look at some examples of strong, oh, sorry, that's not in there really good. Anyway, strong and weak correlation. Let me go ahead and open up here. So believe it or not, Wikipedia, I know some teachers hate it. But I like it. Okay, so let me start sharing here. Where's my share? Okay, so this is called Correlation and Dependence in Wikipedia. Now, here's what I'm trying to say here. We're going to focus primarily on straight line correlation. If it's not a straight line, it's going to be, I mean, other than we're going to take note that it's not a straight line, we're not going to do too much analysis of it. But as you can see here, if this would be perfect correlation, so it's a perfectly straight line, okay? Now this, you got some variation. This is so straight, I would almost wonder if you faked your data, okay? So, so you normally, so this is 0.8, this is 0.4, you can see that there's more spread. This one is zero correlation, there's no correlation. Well, I should be a little bit careful about that. So, well, we'll talk about that in a second. So this kind of a scatter plot would indicate that there's no correlation going on. This would be correlation in the negative direction. So a positive, so correlation, I should mention that. Correlation is always between +1 and -1. So all the positive and negative tells you is positively correlated or negatively correlated. It's not really slope, okay? In fact, as you can see here, all of these are perfectly correlated. These are of equal strength. These are also equally strong correlation. These are positive, these are negative. So negative just kind of implies the direction of your slope, okay? Now, zero correlation often implies there's no correlation, but it has to be backed up by a scatter plot. So correlation and scatter plots, these are related concepts. Correlation is actually a number. The scatter plot is what you can see. So if you get a scatter plot like this is what we call, this one here is what we would call a null plot. Null plot, okay? Means no correlation. And I guess it's time to introduce to you the equation. This is going to be on the test. The equation for correlation is given by the letter R, correlation, I guess. R equals 1 over n minus 1 times the sum of xi minus x bar over s sub x times yi minus y bar over s sub y. Okay? Now, as I mentioned, that's always a number between +1 and -1. So the idea here is if you see something like this, this is what we would refer to as a null plot. This is going to imply that there's no correlation. But on this bottom row here, okay, if you plug these into that equation I just gave to you, okay, correlation here, these all give you a zero correlation. Now, these are what we would say nonlinear correlation. So this equation here assumes a straight line. Those are S's, okay? And in fact, since you asked about that, okay, maybe I'll turn off my sharing here for a second so you can see this equation a little bit better here. As you look at this piece here, what does that look like? It looks like a formula you've already used. What did you say? Okay, I know I got headphones on, but I'm trying to say it louder.
Standard deviation.
Well, this is the standard deviation, but I'm talking about this piece here, this whole in the parentheses. What does that look like? It looks like the Z formula, that's what it is. So this is the Z formula for your X variable. This is the Z formula for your Y variable. This is the sum, and we're going to divide it by n minus 1, okay? So we're going to do that in class, and I'm going to make sure you guys, this is definitely going to be on the test. We're going to go through the steps to find this. But the thing that I want to point out here, before I answer your question really quick here, is that you can plug, if you had data that looked like this on this bottom row here, you can plug this into that formula and it's going to say 0. That does not mean no correlation. It means it's non-linear correlation, okay? You could see something like this. These look fake to me. Well, these two do. These definitely look fake to me, but those have 0 correlation. This one is data that you might see, okay? Kind of a quadratic correlation. This looks like 2 different populations. This looks like a petri dish, kind of fake to me. Those look like you got 4 different populations that are not correlated. Okay, so the thing that you should always do when you're doing correlation, you should always do a scatter plot first. Okay, do the scatter plot first. If you're looking in here and you get something along the top line here, hopefully something like this, okay, then you're going to say yes, correlation is a good idea. If you get something like this or anything on this bottom row, okay. Remember, you can plug it in this equation, but that does not mean it's not correlated. This is definitely correlated in maybe a quadratic direction, okay? But this assumes it's going to be a straight line, Okay? You had a question?
So S is standard deviation.
S is standard deviation. Okay? Yes, so let's just review that one really quickly. Here, I'm going to move my thing over here so you can see over here, hopefully. Yeah, that's pretty good. So just as a reminder, sigma is your population standard deviation. S equals your sample standard deviation. X bar equals your sample mean. And mu equals your population mean. Okay? So that's going to be a key skill for the rest of the semester, especially when we get into hypothesis tests. That's going to become very important to distinguish between whether you have a sample or a population. Okay? So make sure, even though I'm not going to necessarily say, is this a population or sample, you've got to be able to determine that. Okay? Really important skill. Now, so if you wanted to figure out the correlation coefficient by hand, here's some steps to find the correlation coefficient. Okay? Now, I will give you this equation for your test next week. So you can have that. I will not give you the steps, but I'm going to assume here, as we look here, what does X bar and Y bar represent? What'd you say? The sample mean. So that's going to be your first step. Find the mean for your X data and your Y data. What does S sub X and S sub Y mean? Standard deviation. So step 2, find the standard deviation of your X and your Y. Okay. Step 3, what does this represent? This box? So find your standard scores for your X and your Y. What's my next step as I'm doing this here? What am I doing with these standard scores? We're going to multiply standard scores. What does this sigma mean? Sorry, I'll try to turn that a little bit. Okay, say that again. Add them up. Add up. Okay, number 6. I could have written this down here, but I'm just going to say divide by n minus 1. Okay, now, as I mentioned, I'm going to make you guys do this on Excel for the test next week. So if you want to memorize those steps, you can, or if you want to just know, if you know what this, if you can read this equation, you shouldn't have to memorize the steps. Okay? But we'll go ahead and do this. Oh, before I do that, let me just mention a couple other things about standard deviation here. All right. Stop sharing for a second, then I'm going to share something else. Okay, so I'm going to give you a rule that we'll kind of use for the test, and then probably tomorrow I'll break that rule. Okay? So if it's greater than 0.7, if I'm talking about the absolute value here, I'll do it this way. If the absolute value is greater than 0.7, then we're going to call that strong correlation. If it's 0.3 to 0.7, then we're going to call it moderate. And if it's less than 0.3, and I'm talking about absolute value here, we're going to call that weak. Okay? Now, just as I wanted to show you one other thing here.
Is that 1.7?
No, because it can't be greater than 1, remember? It's always between positive, yeah, that's absolute value. Okay, so if I go to Analytic Tech, oh, I swear this should just pop up here. Tech, 313 elements. No, that's not what I wanted. Okay. So the idea with correlation, as you can see here, oh, I can use this, can I? Oh, hallelujah. Okay, so if it's strong correlation, your dots are going to be closer together. If it's weaker, it's going to be more spread apart. Does that make sense? Okay. So some examples here. This would be pretty close to a null plot. Correlation's 0.03. It's very rare that you're going to get exactly 0. But this would you say that this would represent no correlation? Okay. This would be a correlation of 0.28. You can kind of see here as we go along here that there's kind of a general upward trend there. We'd probably call that on the weak side of correlation. As we get stronger, the dots get closer together. This is 0.48. 0.72, this is pretty strong correlation now. 0.89, you can see there's definitely a straight line pattern going on here. 0.99, this is so strong I'd almost wonder if you faked your data, okay? All right, so so that's an example of weak to strong, or even from no to strong correlation. All right, so some patterns to look for. So the idea here is you're looking for something that looks, it can be either in the positive direction or in the negative direction, okay? So this is what we sometimes refer to as the hot dog pattern, okay? You're looking for kind of a hot dog. Your null plot, I'm going to make everybody hungry here. This would be no pattern here, but it looks kind of like a hamburger, right? Hamburger. We're going to make everybody hungry here. And a third pattern would be maybe something that looks like this. What food item does that look like? That looks like a banana. Okay, so we're looking for the hot dog, the hamburger, and the banana. Now the banana is not a straight line, right? Okay, so if you get something like this, this would be non-linear. So therefore, would it be a good idea to find the correlation coefficient if you have a banana? No. So Excel will do whatever you ask it to. It doesn't mean it's a good idea. Okay? So we're hoping for more of a hot dog pattern. Okay? Kind of a straight line pattern. That's what we're going to do. So let's go through. God, we might even get to watch our Netflix video. That'll be cool. Let's go through how to find the correlation coefficient by hand. I believe yeah. Let's go ahead and open up worksheet 4.1. If you go to assignments, in-class worksheets, worksheet 4.1. Okay, so a golfer has chosen to swing a ball on a 70-degree day with no wind. You want to see if there is a relationship between the club head speed and how far the ball goes. Do you think it would make sense? The faster I swing, would the ball go farther as a general rule? Okay, so it seems like there's probably a good idea. If I asked you if you thought your age was correlated with your grade, do you think that would be a strong correlation or a weak correlation or no correlation? What's that?
No correlation.
Probably no correlation, right? Okay, so, but yes, in this case, we'd probably think the faster I swing, the farther the ball will go, right? Okay, so I've got distance in yards and club head is in speed. So these are completely different units. Now, just as a reminder, correlation is unitless. Okay, you can take two completely different things, miles per hour and yards, and you can put them together. Okay, all right, so here's how we're going to do this. The first step you should always do is you should create a scatter plot. So let's pick on, let's see, who do I pick on? I'm going to pick on Sean because I remember your name now. Sean, how would you create a scatter plot? What would be your guess? Speed in yards. Now make sure you include those titles in here like Sean said, okay? And then what? Go to Insert, Scatterplot, just like that. Now that's not labeled very well, right? So how could I label that? Hit the plus sign, add your axis titles. What is this over here?
That's distance.
No, that's not. Oh, that is distance. You're right. Distance in yards. Please put yards in there because, you know, we probably don't know what that is. Feet, yards, miles. Okay. And what goes down here? Where did the measuring this in? This is club, head, speed, and the units are miles per hour. Okay. And this is golf, club, swing on 70-degree day. Okay. All right, so do we think that correlation, linear correlation, is a good idea? Yeah, look at my scatter plot. It looks like roughly a straight line will fit in there pretty well, okay? So we're gonna start doing our correlation coefficient. Okay, so correlation coefficient, this is the equation. What's the first thing I need to do? Find the mean. So I'm gonna find the mean here. Okay, and I'm going to pick on, is it Trevin?
Yeah.
Oh, good. Trevin, how do I find the mean?
Take the sum and divide it by the other.
I could take the sum, or I could use the command, the A word, curse Bill Gates when I do it. Average of all this. So it looks like the mean distance is 101 yards, almost 102. The mean distance is 101 miles an hour. The mean distance is 267 yards, roughly. Okay? All right, so now what is step number 2? I'm going to pick on Stainer.
Step number 2 is finding the standard deviation.
Find standard deviation. Okay, so is this a population or a sample? It looks like a sample, right? So which command should I use to find the standard deviation, or should I make you do it by hand?
So we can use, well, there's a standard deviation function.
Which one should I use?
The sample S.
The dot S. Or I could also use that one too, but the dot S would work. Now, do I want to include my mean in there? No, no. Just want the raw data. Okay? Okay. So the standard deviation is 2.29 miles per hour and 7.74 yards. Okay? Now, what is the third step? I'm going to pick on you because I don't know your name. Tanner, what do I do third? Sorry, I'm blocking it, huh? Find your standard scores. So I want the z-score for the speed and the z-score for the yards. Okay? So Tanner, can you help me do the z-score for the speed? So equals what? No, so what does x sub I represent? It's your data, so what am I going to click on? Click on the 100. We're going to do each one of these points individually, okay? And I'm going to subtract the mean, which is 101.875, and close my parenthesis, divide by 2.29. So I'll click on that. Okay. All right, is that correct? Sort of. Why did you say no? I need the F for that, don't I? Is there anything else that I need to F for? The mean as well, okay? Now let's pretend I forgot to do that, because some of you are going to forget to do that. I'm going to copy that down, and it didn't work. Okay, and that was because, tell me your name again. Hunter. Hunter was smart and said I got to F4 this one because I want that A20 not to change, and I want the A19 not to change too. I always want to subtract out those. Okay, so now when I do it and copy and paste, it works. Okay, so let's pick on Franco. I remember your name. Franco, can you help me get the Z-score for the yards? What does minus to mean? Yeah, what's the first number I'm supposed to click on? Oh, you're not supposed to sit in the back if you can't see the board. Okay. It's the 257 minus 266.75. I probably want to F4 that one, right? Okay, and then I'm going to close my parenthesis. By the way, if you don't put parentheses on there, you'll definitely get the wrong answer. Okay, and then you're going to divide it by which is 7.74. Okay, do I need to F4 that? Yes, I do. Okay. I want the mean and the standard deviation not to change. I want the first number to change when I copy the formula. Okay? All right, so I will copy that down. All right, so step number 4 is what, Chuck? Okay, so I'm going to find the product here. So tell me what to multiply. So the Z speed times the Z yards. Okay, do I need to F4 those? No, I want those to change. Okay, I'm going to copy those down. Okay, what's the next step? Number 5, it must be Jenna's turn. What does step number 5 say? Add them up. What am I adding? Add up the products column. Okay. Get a value of 6.57. What is the last step? I know Tyler's name, but I can't remember yours. Matthew. Okay. What's my N in this case? Is my N 8 or 16? What do you guys think? It's what? It's 8. Okay. So N in this case is your number of pairs. Remember, basically we've got 2 measurements for the same person. The same person is swinging. We're going to measure how fast he swings, and then we're going to measure how far out of the yard ball goes. So these are a pair. So N is your number of pairs in this case. Okay. So if I've got 8 pairs, I'm going to take that number and I'm going to divide by 7. Okay. And I'm going to get an answer of 0.9387. I'm going to pick on Jacob. Would you say that's strong, moderate, or weak correlation? Or that would be strong, right? Because one is as strong as you can get, and it's greater than 0.7, right? Okay. What if I had gotten a negative number? What would you say then? It would still be strong, right? So the positive and the negative doesn't really matter because we're looking, so it's still strong. All right, now, God, I usually cut out the video. This is going to be cool. We're going to watch some Netflix now. Yeah, you have to bring the popcorn yourself. Hopefully, I remember how to sign in. This is always the problem. Oh, hopefully I remember what this is. Oh. Come on. That should have worked. Dang it. I'm sure that's right. Oh well, I'll change it to what I think it should have been. Oh, that's a good idea. Okay, so here I will show you the video and then I will stop recording. You're probably right there. Oh, text me, hurry up. I thought you were already going to do that. Okay, there we go. So here's what we're going to do. Hopefully, is it in my list? I'm watching my list. Oh, I thought it would be there. Freakonomics. This is one of the greatest. Okay, here we go. Okay, I better stop this. But there you go. This is the Freakonomics movie. I'm going to stop so that I don't get in trouble. Stop recording. But watch this at home. We'll talk about it after a minute. Stop sharing. And I'm going to pause recording. Okay, so the one thing that I want to point out here really quickly, whoops. I want to share this really quickly here. Okay, so this was the video that we just watched here about ice cream consumption and polio. Now, the one thing that I want to point out here, does ice cream cause polio? No, sure doesn't, okay? But it sure seems like as we look at this graph, I mean, doesn't that look kind of convincing to you? That seems like there's a relationship. What's that?
Causes diabetes.
It does cause diabetes. Yes, but we're talking about polio here. So what's going on? So you probably heard the well-worn phrase, correlation does not imply causality, right? So I just want to emphasize that again. I don't know why it keeps doing that. Okay, so as we look here, is this linear correlation? Kind of. If you stopped here, it's a nice straight line, right? Or if you did here, it's a nice straight line too. You could kind of break that up into two different sections. Now, the fact of the matter is, even though ice cream does not cause polio, you can use the ice cream sales to predict how many polio sales you'll have, okay? So correlation can be used for prediction, even if ice cream has nothing to do with polio, okay? So I just want to point that out. Now, there is a lurking variable, okay? There is kind of a relationship. We know that ice cream does not cause polio. Do you guys know what does cause polio? A virus. How do you get this virus? If I had polio, would he get it? If I breathed on him? If I coughed on you, you still wouldn't get it. Okay, do you guys know what causes it? What? Yeah, it's a virus in swimming pools and lakes and streams. So there is a sort of relationship because, you know, ice cream sales spike in the summertime when it's super hot. What else do people do in the summertime? They swim in infected lakes and pools. Okay. So there is a lurking variable going on. Okay. So this is a good example of lurking variables, as well as the idea that correlation does not imply causality. But correlation can be used for prediction, even though ice cream doesn't cause polio. So anyway, we got a little bit lucky and got to watch that video. I usually cut that out, but that's kind of cool. So quiz tomorrow is on 4.1. See y'all tomorrow. Oh, that's right.